So this will be part 2 of this follow-up. We are through with this step. Okay, so we are now in step 6, generate points. So in addition to explanatory variables, your prediction model would require an input of uh, presence points or point features that represent a sample of locations for training the model. Create sample locations, that's the point. The presence points will identify locations of known presence for the phenomenon that you are modeling. To create presence points, you generate random points within the study area before combining multiple data sources that identify presence. Using multiple data sources to identify presence can cover any gaps or failures that might exist in one dataset alone. This step, you will begin creating the training datasets of random points across your study area, a region of sub-Saharan Africa that consists of 7 maize producing countries. To generate points in only your study area, you will add a layer to the map that represents the boundary of the 7 countries to be included in your analysis. You will add a layer from a geodatabase in your project to set this boundary. In the catalog pane, expand database and expand maize prediction model in the GDB. Right click study area and choose add to current map. Click in the study area and choose zoom to layer. Okay, so you're going to do that. In case you can just come to view tab, reset pins for mapping. Okay, now the catalog pane is open. Database is maize prediction, and then let it refresh. Okay, so here it is. Right click study area and then add to current map. Alright, that's added. I'll study area to the current map. I can right click on it here and then zoom to layer. So that's just right click and then zoom to layer here. Here's our study area, but let's quickly inspect our study area by going to the attribute table. Okay, and then we have Botswana, Malawi, Mozambique, South Africa, Tanzania, Zambia, and Zimbabwe. So these are the 7 countries. Okay, you can see them here. So let's close that and go back here. Okay, the study area defined on the map. You can now generate random points in your study area. The result will be a point feature class, which is a layer that contains only points. Find and open the create spatial sampling locations data management tool. Create spatial sampling locations. So let's go there. Says create some spatial sampling locations. Okay. Okay, so the tool has opened. So you will specify several parameters for the tool, including the name of the point feature class and the geodatabase where you will store the point feature class. You will also set the constraining feature class to your study area in Africa and specify the number of points to be created. For input study area, click the down arrow and choose study area. For output, type presence points. For sampling method, confirm that simple random is selected. So let's do that. Study area. Presence points. random is selected, and then for number of samples delete 100 and type 1 million 1 2 3 1 2, that's 100,000. So we're going to type 100,000 here, right? The number of points that you choose to create depends on factors such as the size of your study area and the desired distance between points. Leave the remaining default, click run. Okay, so the spatial sampling locations have been added. These are the presence points. Okay, then let's scroll down. Now you have created point feature class of 100,000 random points within your study area in Africa. You will use these points to identify areas of known maize presence. The contents pane, turn off both the presence point layer and the study area layer. Save your project. Now reclassify data, step 7. So we're turning this down. Save the project. After the random points are created for the prediction models training dataset, the data sources specifying the areas of known presence must be incorporated into the training datasets. However, the data sources may require preparations to identify only the values that are needed to classify the presence of maize. Using the reclassifier tool, you can change the values to specify only the values needed to indicate the presence of maize for your prediction model. So we isolate known points. Okay, step 3. So in this step, you will reclassify the values for 2 raster datasets to identify the presence of maize in each raster dataset. The first raster is the gfsad.tif file, which is a global dataset that was created by NASA, the National Aeronautics and Space Administration, using satellite imagery to identify the dominant crop in an area. Find and open reclassify Spatial Analyst tool. So let's go to reclassify. Let's look for reclassify. Reclassify Spatial Analyst tool, and then for input raster, click the down arrow and choose cfsad.tif. So click the down arrow and select this. The layer uses values to identify the dominant crop types. You're interested in maize, which is represented by the values. The layer uses values to identify the dominant crop types. You're interested in maize, which is represented by the values 4, 6, and 7 in the data sets. You classify all 4, 6, and 7 values to 1 to indicate that maize is present. Then reclassify all other values to 0 to indicate that maize is not present. To confirm that the classifier field is set to value. Okay, yep, it's this. Now reclassify the remaining values using the following table as a guide. 1 2 3 4 1 2 3 4 is 1 2 3 is 0 0 0 4 is 1. Okay, clear. Yeah, let's click on unique and see what happens. So this should be 0 0 0. 4 is 1. Rest is 0. 6 is 1. 7 is 1. Rest is 0. 0. So 1 2 3 4 5 6 7 8 9. So we have 0 0 0 0. 4 is 1, 6 is 1, 7 is 1, right? 4 is 1, 6 is 1, 7 is 1. For output as a type ZFSAD underscore maize. Okay. Run. Click run. So we are going to click on run. Okay, the tool has finished running. Okay, nice. That's been reclassified to 0 and 1, which is maize and no maize. Okay, so the GFSAD underscore maize layer is added to the context pane and shows only two values in the layer: 0 for where maize is not grown and 1 for where maize is grown. You now need to reclassify the second dataset to identify where maize is grown. However, this dataset is hosted on ArcGIS Online, so you must first add it to your project. In the contents pane, turn off the GFSAD maize layer. Open the Add Data dialog. On the ribbon, click the Map tab, and in the Layer group, click Add Data. On the left, under Portal, click ArcGIS Online. Search for Africa crop maize. So search for Africa crop maize. Let's just go to the catalog pane, go to portals, and then ArcGIS Online, Africa crop maize. Select the Africa crop maize harvested area layer and click OK. Where is it? This ArcGIS Online now. Africa crop maize. Where is it? I can't find it. Harvested area, right click on it, add to current map. The Africa crop maize harvested area layer shows the average annual area of maize harvested in Africa from 1999 to 2001. This dataset was created by specially disaggregating national and subnational harvest data using a modeled crop presence workflow called the Spatial Production Allocation Model (SPAM). In Spatial Production Allocation Model workflow, the yield of maize harvested across Africa is provided in units of hectares per cell. The dataset uses continuous values rather than unique values to identify areas where maize is grown. For this dataset, values of 180 or less represent areas with higher amounts of hectares of harvested maize. In accordance with the SPAM model, you classify values as are less than or equal to 180 as 1 to indicate areas where more maize is harvested. You also reclassify any value greater than 180 as 0 to indicate areas where either no maize or less maize is harvested. Rather than typing in these values, you will utilize a CSV file. This CSV file named reclassified SPAM has been stored in your data. In the Geospatial pane, open the reclassify by table Spatial Analyst tool. Okay, reclassify by table. Back to the Geospatial. Okay, set or confirm the following parameters. Input raster is Africa crop maize harvested area. Input remap table is reclassify spam.csv. um okay, from value field, from value field is from. Okay, the to value field is to output, value field is output. Okay, output value field is output. So let me just inspect this table and see how it looks like, so we understand this thing better. It has from 0 to 179.9, output is 1. From 180 to 255, output is 0. So this is just the CSV. So from 0 to 179.9 is 1, 180 to 255 is 0. So this is the table. Okay, that's good. Output raster is spam underscore maize. Click run. So you're going to click run. Run. Okay, so the tool has finished running. Okay, and we have these zeros and 1, right? Okay, let's review. So the spam maize layer is added to the map and shows the reclassified value zeros for areas with no or lesser amounts of maize harvested, and 1 for areas with higher amounts of maize harvested. Turn off both this spam maize layer and Africa crop maize harvested area. Save your project. So I'll turn them off. What again? All of them. Save my project. You have reclassified the values for 2 raster datasets to identify where maize is grown. Using multiple datasets to confirm the presence of maize covers any gap or failures that might exist in one dataset. Okay. Let's go to step 8. The next step in preparing your presence data is to extract the data that represents the known locations of maize to the presence points. So extract presence points. The presence only prediction model only requires input data that represents known presence locations. With the values from the data sources reclassified to specify presence locations for maize, you can now extract and add those values to the point feature class layer of the study area presence points. So these values can then be recorded in the layers attribute table for developing your training datasets. In this step, you will extract the values from the GFSAD maize and spam maize raster datasets to the presence points layer to identify areas where maize is present in both raster datasets. In geoprocessing pane, open the extract multi-values to points Spatial Analyst tool. Okay, extract multi-values to points. So let's click on the back arrow and then okay. So we'll click on this tool and then for input raster, click the add many button, check the box for spam maize and GFSAD maize and click add. Okay, so we'll click input. Okay, for the input point feature is the presence points, right? presence points. Then for input rasters is this TF-SAD maze and spam maze, and then we click on add. Those are just two things. Then we click on run. Click run. So let's just click on run. Click on. You have used the extract multi values to point to extract the values from the spam maze raster layer to the presence points layer. Okay. So let's see. Where is the presence points? This. So let's just open the attribute table and see what they mean. So you can see it as extract the values. So you can see maze. You are seeing null values, null, zeros, 1. Okay. So you can see it, right? Extract multi values to point. Sorry, so you can see it now. Extract multi values to points. So you have run the extract multi values to point to. So extract the values from the spam maze and GF-SAD maze raster layer to the presence point layer. The content pane. Open the presence points attribute table. Right click. So you can see it here. Spam maze and GF-SAD maze fields have been added to the presence point attributes table. The GFSAD layer is a TIFF file and the spam layer is an image service. Two common formats of raster GIS data. However, image service provide this the GFSAD layer is a TIFF file and the spam layer is an image service. Two common formats of raster GIS data. However, image service provides more functionality for raster analysis. This difference in data format explains why in the attribute table the spam maze field display null values to represent areas of no data and zeros to represent areas where maze is not present, whereas the GFSAD maze field displays zeros to represent areas of no data as well as where maze is not present. Missing data may also be represented as zeros or as no data. So turn on the presence points layer, save your project, and you can see, right? Okay, turn it on, and then save your map. You've extracted the values from two raster datasets GFSAD maze and spam maze to the presence point layer to identify areas where maze is present in both raster datasets. So step 9 will be to identify presence with attributes. And then step 10 will be extract baseline bioclimate data, and then I think that will be all, but we'll close the session now due to some challenges. So see you in the third session. The third session will be the final session.